Selamat sejahtera. Today my group will be presenting the summary of the final report, the Detachable Plant Pot. Our lecturer in charge is Dr. Azra binti Ismail, myself LINGGESWARY, CD 210327. My group mates are Muhammad AMIRUL ARIF bin HASSAN, CD 210281, and Muhammad Amirdanial bin Hamzah, CD 210308. So a little bit of background study for our project is themed under agriculture. Agriculture is an adaptation of Latin word agricultura, and while agriculture is referred to as human activities, certain species of ant, termite and beetle have been cultivating crops for up to 60 million years. So a subcategory for agriculture is forestry or conservation biology, which includes greenhouse and nurseries, a topic that will be heavily focused in this report to highlight our innovative product. This industry generated almost $200 billion in revenue annually around the world. To make a comparison to another large industry, this is about the same number of jobs in retail clothing and accessory stores. We started out our project with a few problem statements as introduction by applying the starbursting method. So the questions are: is polyethylene bag, or also commonly known as nursery bags, biodegradable? How popular is the usage of polyethylene bag among nurseries, greenhouses and plantation sites? Why use polyethylene bags in such large quantities? How common is the biodegradable bags used, and how long is the shelf life? How much seedling production happens averagely per year? How much is spent per bag, and how many bags are used averagely per year? By answering questions from our problem statements, we came to a conclusion, which is our project, which we named Detachable Plant Pot. Our motto for this project is: you no longer have to wrestle and tear down flimsy nursery bags. The possible materials we finalized for this project are as follows.
Hi doctor, my name is Muhammad Arif bin Hassan. Today I want to present to you about three possible material. First is polylactic, second is polypropylene, and third is copper. First is polylactic. Polylactic is the chemical properties of PLA. Linear and branches J structure. It can be reheat and reformed, but it has low strength in a but it also have a good dimensional stability, good heat resistance and very sensitive to temperature. Since PLA is thermoplastic, its chemical and mechanical properties it should not change, undergoes a melting and solidification. Next is polypropylene, or we call PP. Chemical and mechanical properties of this material include resistance to fatigue, corrosion, chemical leaching, its resilience against most forms of physical damage, including of impact and freezing. Its environmental benefit has ability to join heat fusion. The flash of point composition is 260 Celsius. Auto ignition temperature is 388 something of Celsius. It stands out as an diverse production techniques. PP capacity to work as a plastic and rubber material and another features because it's versatile material to be manufactured variety ways and variety use of polypropylene quick began to challenge many alternative material in another way, particularly in packaging, molding sector. It has maintained its expansion over and is still significant participant in the plastic business. Last one of possible material is copper. Copper is excellent conductor of heat and electricity. It also very malleable and ductile. Copper also a resistant corrosion. It's so soft and tough. A freshly exposed surface of pure copper has a pinkish orange color. Copper is used as a conductor of heat and electricity, as a building material, and as constituent of various metal alloy. Hardness 3 on Mohs scale. Melting point of copper is 1084 Celsius and boiling point at 2562 Celsius. Copper has a face-centered cubic FCC crystal structure. Copper and its alloy have a range of yellow, gold, red colors. When polished, develop a bright metallic luster. Properties of copper extremely suitable for tube forming, wire drawing, spinning, and deep drawing.
Okay, Assalamualaikum dan salam sejahtera. Next, um, my name is Muhammad Amirdanial bin Hamzah. Nombor matrik CD210308. I would like to present about possible process. Okay, finalized process, material fabrication. Number 1, Ziegler-Natta catalyst system. What is the Ziegler-Natta catalyst system? Various production processes exist, all of which have some commonalities. They occur in either gases, in bracket, fluids, bed, or stir reactor, or liquid phases process, in bracket, slurry or solution. Gas phase polymerization is cost-effective and versatile, and it can handle a wide range catalysts. It is the most wide used technology in current polypropylene manufacturing facilities. Okay, next process is about thermoforming. In our presentation, we have the step by step about the process thermoforming. Okay, the first one is making sheet normally by the cast extrusion method. Second step, heating the sheet. Third step, forming the bag by stretching the sheet either into or over a mold. Fourth, cooling the form packaging. Fifth, cutting and trim the multi-unit mold sheet into individual units. This can be carried out at the same time as a forming process. Sixth step, printing or decorating as required. The last step, stacking the individual unit before packaging and labeling for dispatch to the customer. As with all process, quality control throughout is crucial. Okay, next, a process about investment casting. In our slide, we have 3 steps. First step is creating the die or pattern. The first step in the process is to create the die or pattern of the desired workpiece. The pattern is made from the wax. It can pour into a die using injection molding, carved by hand from a block of wax, or print using the 3D printer and the appropriate wax material. Step 2. Mounting the wax pattern. Investment casting molding involves creating multiple wax patterns and attaching this onto a gate device. This device is where metal or other material will be poured to eventually create the desired workpiece. Step 3. Tree assembly. The tree assembly finish the mounting of the wax pattern on the gate device. It is called a tree at this step because each individual wax pattern is essentially a branch and will be one finished workpiece once the process is finalized. You may be seen tree assemblies in new board games that need to have piece detached before use. Okay, next, we was decided that to produce our product, the material used would be red brass alloy with the code C836 or C83600 using the investment casting process and at the end finishing with a coating of the lacquer.
After doing various researches on the prices we found online and on catalogs, this is our financial planning we came up for the product. So for the brass, our cost per unit to produce one pot is 50 cents. The coating lacquer costs around 1 ringgit 12 cents. The labor cost is 3 ringgit and overhead is 1 ringgit. So cost per unit, the total amount is 5 ringgit 62 cents. As you can see, it is very cheap to produce each and every pot, and when compared to the wastage of nursery bags, the amount spent on them and the short shelf life they have, this is very much cheaper. We have come to the conclusion part of our project. So, as you can see, we have chosen agriculture as our theme with the topic detachable plant pot. We have chosen this topic to show that change and innovation does not have to be applied only in the bigger scale of the grand scale of things, but can be also applied at the smaller aspect of daily life to later be developed and bring in, say, bigger positive impacts. Rather than focusing on applying creativity and innovation at large paddy fields and big vegetable cultivating farms, we focused on daily life of houseplants and plants grown in plant nurseries and greenhouses. Beginning from there, we can definitely see a dynamic role of which this innovation being applied towards bigger, more important applications too, such as usage in vegetable farms during replantation, plant cultivating labs, and also greenhouses. Finally, we extend our gratitude on your time and patience for listening to this presentation. Thank you.